Arrays. Data stored in a computer is stored at any location in memory that the computer decides to use. This means that similar pieces of data can be scattered all over memory. This, in itself, doesn't matter to the user, except that to find each piece of data it has to be referred to by a variable name. E.g., if it is necessary to store the 20 names of students in a group, then each location would have to be given a different variable name. The first, Iram, might be stored in location name, the second, Sahin, might be stored in FORENAME, the third, Rashid, could be stored in CHRINAME, but I'm now struggling, and certainly 20 different variable names that made sense will be very taxing to come up with. Apart from anything else, the variable names are all going to have to be remembered. Far more sensible would be to force the computer to store them all together using the variable name. However, this doesn't let me identify individual names, so if I call the first one name 1 and the second name 2, and so on, it is obvious that they are all people's names and that they are distinguishable by their position in the list. Lists like this are called arrays. Because the computer is being forced to store all the data in an array together, it is important to tell the computer about it before it does anything else so that it can reserve that amount of space in its memory, otherwise there may not be enough space left when you want to use it. This warning of the computer that an array is going to be used is called initializing the array. Initializing should be done before anything else so that the computer knows what is coming. Initializing consists of telling the computer what sort of data is going to be stored in the array so that the computer knows what part of memory it will have to be stored in. How many items of data are going to be stored, so that it knows how much space to reserve. The name of the array so that it can find it again. Different programming languages have different commands for doing this, but they all do the same sort of thing. A typical command would be dim $20. Dim is a command telling the computer that an array is going to be used. Name is the name of the array. Tells the computer that the data is going to be characters. 20 tells it that there are going to be up to 20 pieces of data. Notes: just because the computer was told 20 does not mean that we have to fill the array. The 20 simply tells the computer the maximum size at any one time. The array that has been described so far is really only a list of single data items. It would be far more useful if each student had a number of pieces of information about them, perhaps their name, address, date of birth. The array would now have 20 students and more than one thing about each. This is called a two-dimensional array. Obviously, everything gets more complicated now, but don't worry, as it is enough that you understand that an array may well be two-dimensional. If you consider that the names, addresses and dates of birth in this array are then repeated for every group of students in the school, it now can be held as a three-dimensional array. Lots more dimensions are also possible, let's just call them multi-dimensional. To read data into the array, simply tell the computer what the data is and tell it the position to place it in. Example, NAME $11 equals Rashid will place Rashid in position 11 in the array, incidentally, erasing any other data that happened to be in there first. To read data from the array is equally simple. Tell the computer which position in the array and assign the data to another value. Example, result equals NAME $2 will place Sahin into a variable called result. Searching for a particular person in the array involves a simple loop and a question. Example, search for Lou in the array NAME Answer, counter equals 1 while counter is less than 21. Do if NAME counter equals Lou, then print found and end. Else add 1 to counter end while print name not an array. And notice that this is an algorithm written in pseudocode. Try to produce an equivalent algorithm using a repeat until loop structure.